Greetings and salutations, dear viewers. Get ready for some fantastic content. Greetings, explorers of knowledge. Join us as we embark on a quest to understand Intel Core. Intel Core is a line of multi-core with the exception of Core Solo and Core 2 Solo central processing units for mid-range, embedded, workstation, high-end and enthusiast computer market marketed by Intel Corporation. These processors displaced the existing mid to high-end Pentium processors at the time of their introduction, moving the Pentium to the entry level. Identical or more capable versions of Core processors are also sold as Xeon processors for the server and workstation markets. Core was launched in January 2006 as a mobile-only series, consisting of single and dual-core models. It was then succeeded later in July by the Core 2 series, which included both desktop and mobile processors with up to 4 cores, and introduced 64-bit support. Since 2008, Intel began introducing the Core I, Core I, Core I and Core I lineup of processors, succeeding Core 2. A new naming scheme debuted in 2023, consisting of Core 3, Core 5, and Core 7 for mainstream processors, and Core Ultra 5, Core Ultra 7, and Core Ultra 9 for premium high-end processors. Now, let's delve into the intricacies of overview and explore its various aspects. Although Intel Core is a brand that promises no internal consistency or continuity, the processors within this family have been, for the most part, broadly similar. The first products receiving this designation were the Core Solo and Core Duo Xeon processors for mobile from the Pentium M design tree, fabricated at 65nm and brought to market in January 2006. These are substantially different in design than the rest of the Intel Core product group, having derived from the Pentium Pro lineage that predated Pentium 4. The first Intel Core desktop processor and typical family member come from the Conroe iteration, a 65nm dual-core design brought to market in July 2006, based on the Intel Core microarchitecture with substantial enhancements in microarchitectural efficiency and performance, outperforming Pentium 4 across the board or near to it, while operating at drastically lower clock rates. Maintaining high instructions per cycle IPC on a DP propellant and resourced out-of-order execution engine has remained a constant fixture of the Intel Core product group ever since. The new substantial bump in microarchitecture came with the introduction of the 45nm Bloomfield desktop processor in November 2008 on the Hallam architecture, whose main advantage came from redesigned I/O and memory systems featuring the new Intel QuickPath Interconnect and an integrated memory controller supporting up to 3 channels of DRAM memory. Subsequent performance improvements have tended toward making additions rather than profound changes, such as adding the advanced vector extensions AVX instruction set extensions to Sandy Bridge, first released on 32nm in January 2011. Time has also brought improved support for virtualization and a trend toward higher levels of system integration and management functionality, and along with that, increased performance through the ongoing evolution of facilities such as Intel Active Management Technology IAMT. As of 2017, the Core brand comprised 4 product lines: the entry-level I, the mainstream I, the high-end I, and the enthusiast I. Core I was introduced in 2008, followed by I in 2009, and I in 2010. The first Core I models were released in 2017. In 2023, Intel announced that it would drop the I moniker from their processor branding, making it Core. The company would introduce the Ultra branding for high-end processors as well. The new naming scheme debuted with the launch of Raptor Lake U Refresh and Meteor Lake processors in 2024, using the Core branding for mainstream processors and Core Ultra branding for premium high-end processors. Comparison of Intel Core microarchitectures. Overview of Intel Core microarchitectures. The time has come to unravel the secrets behind Core and gain a deeper understanding. The original Core brand refers to Intel's 32-bit mobile dual-core CPUs, which were derived from the Pentium M branded processors. The processor family used an enhanced version of the microarchitecture. It emerged in parallel with the netbusted microarchitecture Intel of the Pentium 4 brand, and was a precursor of the 64-bit core microarchitecture of Core 2 branded CPUs. The Core brand had two branches, the Duo dual-core and Solo single-core, which replaced the Pentium M brand of single-core mobile processor. Intel launched the Core brand on January 6, 2006, with the release of the 32-bit Xeon CPU, Intel's first dual-core mobile low-power processor. Its dual-core layout closely resembled to interconnected Pentium M-branded CPUs packaged as a single die-piece silicon chip IC. Hence, the 32-bit microarchitecture of Core-branded CPUs, contrary to its name, had more in common with Pentium M-branded CPUs than with the subsequent 64-bit Core microarchitecture of Core 2 branded CPUs. Despite a major rebranding effort by Intel starting January 2006, some companies continued to market computers with the Xeon Core marked as Pentium M. The Core series is also the first Intel processor used in an Apple Macintosh computer. The Core Duo was the CPU for the first-generation MacBook Pro, while the Core Solo appeared in Apple's Mac Mini line. Core Duo signified the beginning of Apple's shift to Intel processors across the entire Mac line. In 2007, Intel began branding the Xeon CPUs intended for mainstream mobile computers as Pentium dual-core, not to be confused with the desktop 64-bit Core microarchitecture CPUs also branded as Pentium dual-core. September 2007 and January 4, 2008 marked the discontinuation of a number of Core-branded CPUs, including several Core Solo, Core Duo, Celeron and one Core 2 Quad products. In the following section, we'll be immersing ourselves in the captivating world of Core Solo. Intel Core Solo product code 80538 uses the same two-core die as the Core Duo, but features only one active core. Depending on demand, Intel may also simply disable one of the cores to sell the chip at the Core Solo price. This requires less effort than launching and maintaining a separate line of CPUs that physically only have one core. Intel had used the same strategy previously with the 486 CPU, in which early CPUs were in fact manufactured as CPUs but with the FPU disabled. Conan brand nameless cache socket TDP Xeon Core Solo taxed to MB socket MW Core Solo AUX W. As we enter this new chapter, let's navigate the complexities of Core Duo and unravel its multifaceted nature. Intel Core Duo product code 80539 consists of two cores on one die, a 2 MB cache shared by both cores, and an arbiter bus that controls both the cache and FSB frontside bus access. Conan brand nameless cache socket TDP Xeon Core Duo taxed to MB socket M31W Core Duo laxed 15W Core Duo AUX 9W. Get ready for an enlightening exploration as we dig into Core 2 and understand its role in the broader context. The successor to Core is the mobile version of the Core 2 line of processors based on the Core microarchitecture, released on July 27, 2006. The release of the mobile version of Intel Core 2 marks the reunification of Intel's desktop and mobile product lines, as Core 2 processors were released for desktops and notebooks. Unlike the first Intel Core CPUs that were targeted only for notebooks, although they were used in some small form factor and all-in-one desktops, like the iMac and the Mac Mini. Unlike the original Core, Intel Core 2 is a 64-bit processor, supporting Intel Extended Memory 64 technology INT. Another difference between the original Core Duo and the new Core 2 Duo is an increase in the amount of Level 2 cache. The new Core 2 Duo has tripled the amount of onboard cache to 6 MB. Core 2 also introduced a quad-core performance variant to the single and dual-core chips, branded Core 2 Quad, as well as an enthusiast variant, Core 2 Extreme. All three chips are manufactured at a 65 mm lithography, and in 2008, a 45 mm lithography, and support front-side bus speeds ranging from 533 ms to 1.6 ms. In addition, The 45nm die shrink of the core microarchitecture adds C support to all Core 2 microprocessors manufactured at a 45nm lithography, therefore increasing the calculation rate of the processors. In the upcoming section, we'll be dissecting Core 2 Solo and exploring its intricate connections to our topic. The Core 2 Solo, introduced in September 2007, is the successor to the Core Solo and is available only as an ultra-low power mobile processor with 5.5 watt thermal design power. The original AUX series Merom L used a special version of the Merom chip with CPU ID number 10661 Model 22, stepping that only had a single core and was also used in some Xeon processors. The later SUT6 are part of Intel's CULV range of processors in a smaller FPGA956 package but contained the same Pentium chip as the dual-core variants, with one of the cores disabled during manufacturing. Codename brand name is Cache Socket TDP Merom L Mobile Core 2 Solo AUX 1 MB FCBGA 5.5W Pentium L Mobile Core 2 Solo SUT6 3 MB GA 5.5W. As we progress through this video, let's shift our attention towards Core 2 Duo and uncover its hidden depths. The majority of the desktop and mobile Core 2 processor variants are Core 2 Duo with 2 processor cores on a single Merom, Conroe, Allendale, Pentium, or Warfel chip. These come in a wide range of performance and power consumption, starting with the relatively slow ultra-low power UX10W and low-power LAX17W versions, to the more performance-oriented UX25W and TAX35W mobile versions and the XAX65W desktop models. The mobile Core 2 Duo processors with an S prefix in the name are produced in a smaller FPGA956 package, which allows building more compact laptops. Within each line, a higher number usually refers to better performance, which depends largely on core and front side bus clock frequency and amount of second-level cache, which are model-specific. Core 2 Duo processors typically use the full cache of 2, 3, 4, or 6 MB available in the specific stepping of the chip, while versions with the amount of cache reduced during manufacturing are sold for the low-end consumer market as Xeon or Pentium dual-core processors. Like those processors, some low-end Core 2 Duo models disable features such as Intel virtualization technology. Brace yourself for a captivating discussion on Core 2 Quad as we explore its nuances and implications. Core 2 Quad processors are multi-chip modules consisting of 2 dies similar to those used in Core 2 Duo, forming a quad-core processor. This allows twice the performance of a dual-core processors at the same clock frequency in scenarios that take advantage of multi-threading. Initially, all Core 2 Quad models were versions of Core 2 Duo desktop processors, Kentsfield derived from Conroe and Yorkfield from Warfel, but later Pentium QC was added as a high-end version of the mobile dual-core Pentium. The Xeon AUX and AUX processors are mostly identical versions of the desktop Core 2 Quad processors and can be used interchangeably. Codename brand name Little Cache Socket TDP Kentsfield Core 2 Quad COX MBLG A775W Yorkfield Core 2 Quad COX MBW Core 2 Quad COX MB Pentium QC Mobile Core 2 Quad COX MB Socket P45W. Welcome to the next segment, where we explore Core 2 Extreme and its significance in our journey. Core 2 Extreme processors are enthusiast versions of Core 2 Duo and Core 2 Quad processors, usually with a higher clock frequency and an unlocked clock multiplier, which makes them especially attractive for overclocking. This is similar to earlier Pentium D processors labeled as Extreme Edition. Core 2 Extreme processors were released at a much higher price than their regular version, often $999 or more. Codename brand name list cache socket TDP Merom XE Mobile Core 2 Extreme XAX 4 MB socket P44W Comro XE Core 2 Extreme XAX 4 MB LGA 775 Kentsfield Core 2 Extreme Kix MB LGA 775 130W Penryn XE Mobile Core 2 Extreme XAX 6 MB socket P44W Penryn QC XE Mobile Core 2 Extreme Chi MB socket P45W Yorkfield Core 2 Extreme Kix MB LGA 775 LGA 771W. Let's transition to first generation and uncover its significance. With the release of the Nhlm microarchitecture in November 2008, Intel introduced a new naming scheme for its core processors. There are three variants, Core I, and Core I, but the names no longer correspond to specific technical features like the number of cores. Instead, the brand is now divided from low-level I, through mid-range I to high-end performance I, which correspond to 3, 4, and 5 stars in Intel's Intel processor rating following on from the entry-level Xeon 1 star and Pentium 2 stars processors. Common features of all Nhlm-based processors include an integrated memory controller as well as Quick Path Interconnect or PCI Express and direct media interface on the processor, replacing the aging quad-pumped front-side bus used in all earlier core processors. All these processors have 256 KB cache per core, plus up to 12 MB shared cache. Because of the new IO interconnect, chipsets and mainboards from previous generations can no longer be used with Nhlm-based processors. Intel intended the Core I as the new low end of the performance processor line from Intel, following the retirement of the Core 2 brand. The first Core I processors were launched on January 7, 2010. The first Nhlm-based Core I was Clarkdale-based, with an integrated GPU and 2 cores. The same processor is also available as Core I and Pentium, with slightly different configurations. The Core iX processors are based on Arundel, the mobile version of the Clarkdale desktop processor. They are similar to the Core iX series but running at lower clock speeds and without turbo boost. According to an Intel FAQ, they do not support error correction code ECC memory. According to motherboard manufacturer Supermicro, if a Core I processor is used with a server chipset platform such as Intel, the CPU supports ECC with UDIMM. When asked, Intel confirmed that, although the Intel 5 series chipset supports non-ECC memory only with the Core I or I processors, using those processors on a motherboard with 3400 series chipsets it supports the ECC function of ECC memory. A limited number of motherboards by other companies also support ECC with Intel Core X processors. A Asus WS is an example, but it does not support ECC memory under Windows non-server operating systems. Linfield were the first Core I processors using the Nhlm microarchitecture, introduced on September 8, 2009, as a mainstream variant of the earlier Core I. Linfield Core I processors have an 8 MB cache, a DMI bus running at 2.5 GHz and support for dual-channel DRAM memory and have hyperthreading disabled. The same processors with different sets of features, hyperthreading and other clock frequencies enabled, are sold as Core iX and Xeon 3400 series processors, which should not be confused with high-end Core iX and Xeon 3500 series processors based on Bloomfield. A new feature called Turbo Boost technology was introduced, which maximizes speed for demanding applications, dynamically accelerating performance to match the workload. After Nhlm received the 32 Westler die shrink, Arundel, the dual-core mobile Core I processors and its desktop counterpart Clarkdale was introduced in January 2010. Together with Core iX and Core iX processors based on the same architecture. Arundel processors have integrated graphics capability. Core iX does not support for Turbo Boost. The cache in Core iX processors is reduced to 3 MB, while the Core iX uses the full cache. Clarkdale is sold as Core iX, along with related Core I and Pentium processors. It has hyper-threading enabled and the full 4 MB cache. According to Intel, Core i desktop processors and desktop boards typically do not support ECC memory, but information on limited ECC support in the Core i section also applies to Core i and i. The Core i brand targets the business and high-end consumer markets for both desktop and laptop computers, and is distinguished from the Core i entry-level consumer, Core i mainstream consumer, and Xeon server and workstation brands. Introduced in late 2008, Bloomfield was the first Core i processors based on the Nehalem architecture. The following year, Linfield desktop processors and Clarksfield mobile processors brought new quad-core Core i models based on the said architecture. After Nehalem received a 32 Westler die shrink, Arundel dual-core mobile processors were introduced in January 2010, followed by Core i's first 6-core desktop processor Gulftown on March 16, 2010. Both the regular Core i and the Extreme Edition are advertised as 5 stars in the Intel processor rating. The first generation Core i uses 2 different sockets, LGA 1366 designed for high-end desktops and servers, and LGA 1156 used in low and mid-end desktops and servers. In each generation, the highest performing Core i processors use the same socket and QPI-based architecture as the medium-end Xeon processors of that generation, while lower performing Core i processors use the same socket and CMIFI architecture as the Core i. Core i is a successor to the Intel Core 2 brand. Intel representatives stated that they intended the moniker Core i to help consumers decide which processor to purchase as Intel releases new Nehalem-based products in the future. The spotlight now falls on second generation as we delve deeper into its details. In early 2011, Intel introduced a new microarchitecture named Sandy Bridge. This is the second generation of the Core processor microarchitecture. It kept all the existing brands from Nehalem, including Core E, and introduced new model numbers. The initial set of Sandy Bridge processors includes dual and quad-core variants, all of which use a single 32 die for both the CPU and integrated GPU cores, unlike the earlier microarchitectures. All Core E processors with the Sandy Bridge microarchitecture have a 4-digit model number. With the mobile version, the thermal design power can no longer be determined from a 1 or 2-letter suffix but is encoded into the CPU number. Starting with Sandy Bridge, Intel no longer distinguishes the code names of the processor based on number of cores, socket, or intended usage. They all use the same code name as the microarchitecture itself. Ivy Bridge is the codenym for Intel's 22 die shrink of the Sandy Bridge microarchitecture based on tri-gate transistors, introduced in April 2012. Released on January 20, 2011, the Core iX line of desktop and mobile processors is a direct replacement of the 2010 Clarksville Core iX and Arundel Core iX models, based on the new microarchitecture. While they require new sockets and chipsets, the user-visible features of the Core i are largely unchanged, including the lack of support for Turbo Boost and AES-NI. Unlike the Sandy Bridge-based Celeron and Pentium processors, the Core i line does support the new advanced vector extensions. This particular processor is the entry-level processor of this new series of Intel processors. In January 2011, Intel released new quad-core Core i processors based on the Sandy Bridge microarchitecture at CES 2011. New dual-core mobile processors and desktop processors arrived in February 2011. The Core iX line of desktop processors are mostly quad-core chips, with the exception of the dual-core Core iRT, and include integrated graphics, combining the key features of the earlier Core iX and Core iX lines. The suffix after the 4-digit model number designates a NOC multiplier K, low power S and ultra low power T. The desktop CPUs now all have 4 non-SMT cores like the i750, with the exception of the iRT. The DMI bus runs at 5 TS. The mobile Core iX SoCs processors are all dual-core and hyper-threaded chips like the previous Core iX series, and share most of the features with that product's line. The Core i brand was the high-end for Intel's desktop and mobile processors until the announcement of the i in 2017. Its Sandy Bridge models feature the largest amount of cache and the highest clock frequency. Most of these models are very similar to their smaller Core i siblings. The quad-core mobile Core i processors follow the previous Clarksfield Core i processors, but now also include integrated graphics. In this part of the video, we'll be delving deeper into third generation and analyzing its key components. Ivy Bridge is the codename for a third-generation line of processors based on the 22 manufacturing process developed by Intel. Mobile versions of the CPU were released in April 2012, following with desktop versions in September 2012. The Ivy Bridge-based Core i line is a minor upgrade to 22 process technology and better graphics. In this section, we'll be peeling back the layers of fourth generation to reveal its true essence. Haswell is the fourth-generation core processor microarchitecture and was released in 2013. Let's now shift gears and explore fifth generation through a critical lens, uncovering its strengths and weaknesses. Broadwell is the fifth-generation core processor microarchitecture and was released by Intel on September 6, 2014, and began shipping in late 2014. It is the first to use a 14-chip. Additionally, mobile processors were launched in January 2015 and desktop Core i and i processors were released in June 2015. Desktop processor DT series. Mobile processors U series. Mobile processors Y series. Let's now shift gears and explore Skylake microarchitecture through a critical lens, uncovering its strengths and weaknesses. Skylake is the sixth-generation core processor microarchitecture and was launched in August 2015. Being the successor to the Broadwell line, it is a redesign using the same 14 manufacturing process technology. However, the redesign has better CPU and GPU performance and reduced power consumption. Intel also disabled overclocking non-K processors. Processor branding model corresponds with cache GPU model socket TDP process EO bus release date Core i 8 MB HD 530 LGA 115191 W14 direct media interface. Integrated GPU August 2015 6000, 765W September 2015 at 35W Iris Pro 58065W May 2016 Core i6 MB HD 53091W September 2015 6000, 665W 6000, 506,400 HD 510 December 2015 X HD 530 35W June 2016 X September 2015 Core i6000, 324 MB HD 530 51 W6000, 300 at 35W6000, 103 MB HD 530 51 W at 35W up HD 510 54W December 2015. Desktop processors DT series. Processor branding model corresponds with cache GPU model socket TDP process EO bus release date Core i3 MB HD 530 FPGA 1356 35W14 direct media interface. Integrated GPU September 2015. Mobile processors H series. Processor branding model corresponds with cache GPU model socket TDP process EO bus release date Core i4 MB Iris 540 FCBG A 1356 15W14 direct media interface. Integrated GPU September 2015 OHD 520 25W Iris 550 28W IGZU Iris 540 15W IGZU HD 520 Core IGZU Iris 550 28W Iris 549.5W HD 520 15W Iris 543 MB HD 500 520 Core IO HD 550 28W HD 520 15 W HD 520 November 2016. Mobile Processors U Series. With our foundation established, it's time to explore Skylake microarchitecture and its relevance to our overarching theme. Processor branding model chorus with the cache socket TDP process EO bus price Core iXe 24.75 MB LG at 2066 165 W14 direct media interface $1,999 x 22 MB $1,699 x 19.25 MB $1,399 x 16.5 MB 140 W $1,199 x 13.75 MB $999 Core iX11 MB $599 x 8.25 MB $389. High-end desktop processors X series. The time has come to unravel the secrets behind Kaby Lake and gain a deeper understanding. Kaby Lake is the codenym for the 7th generation core processor and was launched in October 2016 mobile chips and January 2017 desktop chips. With the latest generation of microarchitecture, Intel decided to produce Kaby Lake processors without using their tick-tock manufacturing and design model. Kaby Lake features the same Skylake microarchitecture and is fabricated using Intel's 14nm manufacturing process technology. Built on an improved 14 processor, Kaby Lake features faster CPU clock speeds and turbo frequencies. Beyond these process and clock speed changes, little of the CPU architecture has changed from Skylake, resulting in identical IPC. Kaby Lake features a new graphics architecture to improve performance in graphics and video playback. It adds native high-bandwidth digital content protection 2.2 support, along with fixed-function decoder MPEG-4 AVC, high-efficiency video coding main and main bit, and 10-bit and 8-bit video. Hardware encode is supported for MPEG-4 AVC, HEVC main bit, and 8-bit video. 10-bit encode is not supported in hardware. OpenCL 2.1 is now supported. Kaby Lake is the first core architecture to support hyperthreading for the Pentium branded desktop CPU SKU. Kaby Lake also features the first overclocking-enabled I-branded CPU. Features common to desktop Kaby Lake Quasar 1151 socket DMI3 and C3 interfaces, dual-channel memory support in the following configurations: Dell 1600 1.35 v 32GB maximum, Ultra 2400 1.2 v 64GB maximum, a total of 16 PC lanes. The core branded processors support the UX instruction set. The Xeon and Pentium branded ones support only C315's base graphics clock rate, no cache headroom. A release date of January 3, 2017. Processor branding model cores threads CPU clock rate, CPU turbo clock rate, GPU model maximum GPU clock rate, cache TDP price USD single core dual core quad core Core iX 48 4.2 4.5 4.4 4.4 HD 630 11 15 8 MB 7700 3.6 4.2 4.1 465 W300 and $12 at 2.9, 3.8, 3.7, 3.6, 35 W Core iX 44 3.8, 4.2, 4.1, 4.6 MB 91 W200 and $43 7,600 3.5, 4.1, 3.9, 65 W200 and $24 at 2.8, 3.7, 3.6, 3.5 1135 W7000 500 3.4 3.8 3.7 3.6 65 $202 at 2.7 3.3 3.2 3.1 35 $7,000 403 3.5 3.4 3.3 1,000 65 $182 at 2.4 2.9 2.7 35 $187 Core I at 244.2 Smart 11 15s for MB 60 $179 7,000 324.1 51 $157 7,000 304 $147 at 3.5 1135 $7,000 103.9 3 MB 51 $117 at 3.4 35 WI 3.9 54 W at 3.4 35 W. Desktop processors S-Series. Processor branding model cores threads CPU clock rate CPU turbo clock rate GPU clock rate cache max. C lanes TD peak release date price USD single core dual core quad core base max. Up down core i4 3.1 4.1 3.9 3.7 HD 600 and 3350 1100 8 MB 1645 W 2.9 3.9 3.7 3.5 $378 at 2.8 3.8 3.6 3.4 6 MB core i4 for $1,250 $2.5 3.5 3.3 3.1 core i243 not $950 3 MB 35 W not $225. Mobile processors H-Series. Processor branding model cores threads CPU clock rate CPU turbo clock rate GPU clock rate cache max. C lanes TD peak release date price USD single core dual core base max. Up down core IU2 for 2.5 Forks. RS plus 600 and 4300 1100 4 MB 64 MB 1215 W not 2.8 3.9 HD 600 and 2011 not 25 W 7.5 W $393 3.5 Forks RS plus 600 and 64 MB 28 W not 23 W. 2.4 3.8 RS plus 600 and 40 10 15s 15 W 9.5 W 2.7 3.5 HD 600 and 20 0 25 W 7.5 W 2016 $393 Core I 2.3 3.6 RS plus 600 and 41,000 for MB 64 MB 1215 W not 9.5 W 2017. 2.6 3.5 HD 600 and 1100 MB not 1215 W 25 W 7.5 W $281 3.3 3.7 RS plus 600 and 54 MB 64 MB 28 W not 23 W. 3.1 3.5 10 15s 2.2 3.4 RS plus 600 and 4900 and 15s 15 W 9.5 W 2.5 3.1 HD 600 and 21,000 3 MB not 25 W 7.5 W 2016 $281 Core I 2.8 SNOT RS plus 600 and 51,000 3 MB 64 MB 1228 W not 23 W 2017. 2.4 HD 600 and 20 not 15 W 7.5 W 2016 $281. Mobile processors U-Series. Processor branding model cores threads CPU clock rate CPU turbo clock rate GPU clock rate cache max. C lanes TD peak release date price USD single core dual core base max. Up-down Core i2 for 1.3, 3.6, 3.4 HD 615 310 15s for MB10 4.5 W7W Core i1.2 3.3 2.9 915s 2017 $281 i3.2 2.8 2016 Core i1 2.6 900s i1.1 3 2017. Mobile processors Y series. Kaby Lake X processors are modified versions of Kaby Lake S processors that fit into the LGA 2066 socket. However, they can't take advantage of the unique features of the platform. Processor branding model cores threads CPU clock rate CPU turbo clock rate cache TDP price USD single core dual core quad core core iX48 4.3 4.5 4.4 4.4 8 MB core iX44 4.2 4.1 6 MB. High-end desktop processors X series. As we progress, let's zoom in on Kaby Lake refresh and examine its role in shaping our overall narrative. Mobile processors U series. Get ready for an enlightening exploration as we dig into Coffee Lake microarchitecture and understand its role in the broader context. Coffee Lake is a codenym for the 8th generation Intel Core family and was launched in October 2017. For the first time in the 10-year history of Intel Core processors, the Coffee Lake generation features an increase in core counts across the desktop lineup of processors, a significant driver of improved performance versus previous generations despite similar per-clock performance. Increase in number of CPU cores in desktop Coffee Lake processors. Intel hyper-threading capabilities allow an enabled processor to execute 2 threads per physical core. Coffee Lake features largely the same CPU core and performance perms as Skylake Kaby Lake. Features specific to Coffee Lake include the following similar refinements to the 14 process in Skylake and Kaby Lake. Coffee Lake is the third 14 process refinement and features increased transistor gate pitch for a lower current density and higher leakage transistors, which allows higher peak power and higher frequency at the expense of die area and idle power. Coffee Lake will be used in conjunction with the 300 series chipset and is incompatible with the older 100 and 200 series chipsets. Increase the cache in accordance to the number of cores. Increased turbo clock speeds across I and iQuest models increased by up to 200 ms. Increased clock speeds by 15 ms. Memory support updated for 2666 ms for I and I parts and 2400 ms for I parts. Memory is no longer supported. Desktop processors S series. Processors Core i8100 and Core i with stepping actually belong to Kaby Lake S family. Processor branding model cores threads CPU clock rate max. Turbo clock rate GPU clock rate cache TDP price USD base max. Down up Core i6 12 2.6 4.3 UHD 630 315s 1.15 9 MB 45 W35 W2.2 4.1 1.1 3.2 4.6 1.2 12 MB 65 W303 Core i663 4.1 1.1 9 MB 190 $2 up 2.8 Forbes 1.05 $182 for 8 2.5 4.2 1.1 8 MB 45 W250 2.3 Forbes 1 $250 Core i443 no 6 MB $225. Mobile processors H series. Processor branding model cores threads CPU clock rate max. Turbo clock rate GPU clock rate cache RAM TDP price USD base max. Down up Core i2 48 2.7 4.5 Iris plus 655 300s 1.28 MB 128 MB 28W 20W Core i2 2.6 4.2s 1.16 MB $320 2.3s 3.8 1.05 SNO Core i2 243 3.6 UHD 631.1 MB. Mobile processors U series. With the foundation laid, let's embark on a journey into Amber Lake microarchitecture. Amber Lake is a refinement over the low-power mobile Kaby Lake processor, branding model, cores, threads, CPU clock rate, GPU max, GPU clock rate, cache TDP, price base max, turbo up down, Core i2 for 1.8 3.9 to HD 617 1015s 4 MB 7W NOI 1.5 4.2 to HD 615 5W 7W 3.5 W $393 Core i 1.6 3.9 to HD 617 7W NOI $281 E 3.6 E 1.3 3.9 to HD 615 915s 5W 7W 3.5 W $291 Core Mi 1.1 3.4 900s 8W 4.5 W $281. Mobile processors Y series. Brace yourself for an enlightening exploration of Whiskey Lake microarchitecture as we dive into its profound implications. Whiskey Lake is Intel's codenym for the third 14 Skylake process refinement, following Kaby Lake Refresh and Coffee Lake. Intel announced low-power mobile Whiskey Lake's availability on August 28, 2018. It has not yet been advertised whether this CPU architecture contains hardware mitigations for meltdown. Spec class vulnerabilities of various sources contain conflicting information. Unofficially, it was announced that Whiskey Lake has hardware mitigations against meltdown, and while Spectre requires software mitigations as well as microcode firmware update. Mobile processors U series. As we venture forward, let's examine Cannon Lake microarchitecture in detail and gain a deeper appreciation for its significance. Cannon Lake, formerly Skymint, is Intel's codenym for the 10nm die shrink of the Kaby Lake microarchitecture. As a die shrink, Cannon Lake is a new process in Intel's process-architecture optimization execution plan as the next step in semiconductor fabrication. Cannon Lake are the first mainstream cores to include the AVX 512 instruction set. In comparison to the previous generation of AVX 256, the new generation AVX 512 most notably provides double the width of data registers and double the number of registers. These enhancements would allow for twice the number of floating point operations per register due to the increased width, in addition to doubling the overall number of registers, resulting in theoretical performance improvements of up to 4 times the performance of UX. At CES 2018, Intel announced that they had started shipping mobile Cannon Lake cores at the end of 2017 and that they would ramp up production in 2018. No further details were disclosed. Processor, branding model, cores, threads, CPU clock rate, CPU turbo clock rate, GPU clock rate, cache TDP, price USD base max. Down Core i2 for 2.2 3.2 NO 4 MB 15W NO. Mobile processors U series. Now, let's delve into the intricacies of Skylake microarchitecture and explore its various aspects. The 9th generation Coffee Lake cores are updated versions of previous Skylake X series cores with clock speed improvements. Processor, branding model, core, threads, base clock, single core, turbo clock, cache TDP, price, Core iXE3 4.5 24.75 MB 165 W $1,979 x 3.1 22 MB $1,684 x 3.3 19.25 MB $1,300 $387 x 3.5 is $1,189 x $989 x 3.3 is 4.2 16.5 MB $889 Core i x 3.8 is 4.5 is $589. High-end desktop processors X series. With the foundation laid, let's embark on a journey into Coffee Lake Refresh microarchitecture. The 9th generation Coffee Lake bus were released in the fourth quarter of 2018. They include hardware mitigations against certain meltdown spectra vulnerabilities. For the first time in Intel consumer CPU history, these bus support up to 128 GB RAM. 8th generation 9th generation Core i4 444 Core i6 666 Core i6 1288 Core i6 12816. Increase in number of CPU cores in desktop 9th generation processors. Intel hyper-threading capabilities allow an enabled processor to execute 2 threads per physical core. Even though the Fahrenheit suffix CPUs lack an integrated GPU, Intel set the same price for these CPUs as their featureful counterparts. Desktop processors S-series. Various reviews show that the Core i-X CPU may consume over 140 W under load. The Core i-X may consume even more. Mobile processors H-series. In this part of the video, we'll be diving deep into Cascade Lake microarchitecture and unraveling its profound impact. Cascade Lake X series CPUs are the 10th generation versions of the previous Skylake X series CPUs. They offer minor clock speed improvements and a highly reduced price. Processor branding model Chorus Threads-based clock single core turbo clock all core turbo clock cache TDP price Core i-Xe3 4.8 3.8 24.75 MB $165 $979 x 3.3 4.1 19.25 MB $784 x 3.5 4.3 $689 x 3.7 4.7 $590. High-end desktop processors X series. Get ready for an exciting exploration as we unravel the mysteries of Ice Lake microarchitecture. Ice Lake is codename for Intel's 10th generation Intel Core processors, representing an enhancement of the architecture of the preceding generation Kaby Lake Cannon Lake processors as specified in Intel's Architecture Optimization Execution Plan. As the successor to Cannon Lake, Ice Lake uses Intel's newer 10 fabrication process and is powered by the Sunny Cove microarchitecture. Ice Lake are the first Intel CPUs to feature in silicon mitigations for the hardware vulnerabilities discovered in 2017, Meltdown and Spectre. These side-channel attacks exploit branch predictions use of speculative execution. These exploits may cause the CPU to reveal cached private information which the exploiting process is not intended to be able to access as a form of timing attack. Mobile processors U-series. Mobile processors Y-series. As we enter this new chapter, let's navigate the complexities of Comet Lake microarchitecture and unravel its multifaceted nature. Comet Lake is Intel's codename for the 414 Skylake process refinement, following Whiskey Lake. Intel announced low-power mobile Comet Lake CPUs availability on August 21, 2019. 9th generation 10th generation Core i4 448 Core i6 12 Core i8 16 Core i8 16 1020. Increase in number of CPU cores in desktop 10th generation processors. Desktop processors S-series. Mobile processors H-series. Mobile processors U-series. Get ready for a thought-provoking discussion as we delve into Amber Lake Refresh microarchitecture and its impact on our understanding. List of Amber Lake Refresh Y-series processors. Moving forward, we'll be taking a closer look at Tiger Lake. Launched on September 2, all models support 3200 memory. All models support 20 reconfigurable PCI Express for lanes, allowing Xgen for link for discrete GPU and Xgen for link for MSTs. With that being said, let's now move on to mobile processors Tiger Lake H. Mobile processors Tiger Lake H. As we venture forward, let's take a closer look at mobile processors Tiger Lake and its impact on our understanding. Mobile processors Tiger Lake high-all models support the 3200 all tracks 4267 memory. Processor branding model cores threads base freak at TDP max turbo freak active cores iris C graphics smart cache TDP price WW12 all use max freak core i4 8 2.9 3.4 5 4.6 96 1.4 3 3.3 5 4.8 4.3 1.35 $482 4.8 $426 core i 2.5 3.2 4.5 8 MB $309 2.6 3.1 4.4 81.3. Let's now venture into the realm of mobile processors up class and explore the fascinating intricacies it holds. Mobile processors up class. Processor branding model cores threads base freak at TDP max turbo freak GPU smart cache TDP memory support price WWW series use max freak type ECC core I agreed pro 48 1.2 1.8 2.8 4.4 iris C96 1.35 erg pro no $431 core I agreed pro 1.1 1.5 2.6 4.1 81.38 MBS erg pro no $312 core I agree to for 1.7 2.2 3.9 UHD 48 1.25 erg no $285. Embedded mobile processors up class. In the next portion, we'll be immersing ourselves in the realm of mobile processors up class and examining its broader implications. Mobile processors up class. Moving forward, we'll be taking a closer look at desktop processors Tiger Lake B. Desktop processors Tiger Lake socket, BGA socket. Thus these CUS are meant only for system integrators. Intel CUHD graphics up to 128 GB 3200 memory was initially incorrectly listed as having a 5.3 TDP boost frequency. Processor branding model cores threads base boost clocks cache MVTDP GPU GPU max freak price core i11900 KB 816 3.3 4.9 2465 W30 to 1.45 $539 core IURB 3.2 4.8 core IURB 612 3.3 4.612 core IURB 48 3.6 4.4 16 1.4. Now, let's shift our focus to Rocket Lake microarchitecture and embark on an intellectual exploration of its various dimensions. Rocket Lake is a codenym for Intel's desktop chip family based on the new Cypress Cove microarchitecture, a variant of Sunny Code used by Intel's Ice Lake mobile processors backported to the older 14 process. The chips are marketed as Intel 11th generation core. Launched March 30, 2021. In the upcoming section, we'll be dissecting desktop processors and exploring its intricate connections to our topic. All CUS listed below support the 3200 natively. The Core ICF processors enable a ratio of DRAM to memory controller by default at the 3200, whereas the Core I non-CF and all other CUS listed below enable a ratio of DRAM to memory controller by default at the 3200 and a ratio by default at the 2933. All CUS support up to 128 GB of RAM in dual-channel mode Core ICPUS except at support Intel Thermal Velocity Boost technology. Get ready for an enlightening exploration as we dig into Alder Lake and understand its role in the broader context. Alder Lake is Intel's codenym for the 12th generation of Intel Core processors based on a hybrid architecture utilizing Golden Cove high-performance cores and Gracemont power-efficient cores. It is fabricated using Intel's Intel 7 process, previously referred to as Intel 10 Enhanced Superfin ISF. Intel officially announced 12th Gen Intel Corpus on October 27, 2021, and was launched to the market on November 4, 2021. Now, let's shift our focus to desktop processors Alder Lake S and embark on an intellectual exploration of its various dimensions. Desktop processors Alder Lake Corpus support up to 128 GB of the 3200 or 4800 RAM in dual-channel mode. Some models feature integrated UHD graphics 770, UHD graphics 730 or UHD graphics 710 GPU with use and base frequency of 300 Ms. By default, Alder Lake Corpus are configured to run at turbo power at all times, and base power is only guaranteed when peak cores do not exceed the base clock rate. Max turbo power, the maximum sustained 1s power dissipation of the processor as limited by current and the temperature controls. Instantaneous power may exceed maximum turbo power for short durations 10 ms. Maximum turbo power is configurable by system vendor and can be system specific. Corpus in bold below feature ECC memory support only when paired with a motherboard based on the wood chipset. By default, Core iX achieves 5.5 Gs only when using thermal velocity boost. Brace yourself for an enlightening exploration of extreme performance mobile processors Alder Lake HX as we dive into its profound implications. Extreme performance mobile processors Alder Lake bold indicates ECC memory support. In this section, we'll be peeling back the layers of high-performance mobile processors Alder Lake H to reveal its true essence. High-performance mobile processors Alder Lake H. Let's zoom in on low-power performance mobile processors Alder Lake P and understand its implications. Low-power performance mobile processors Alder Lake P. As we transition to the next segment, let's unravel the mysteries surrounding ultra-low power mobile processors Alder Lake U and gain a fresh perspective. Ultra-low power mobile processors Alder Lake U. Prepare yourself for an in-depth analysis of Raptor Lake in this section. Raptor Lake is Intel's codename for the 13th generation of Intel Core processors and the second generation based on a hybrid architecture. It's fabricated using an improved version of Intel's Intel 7 process. Intel launched Raptor Lake on October 22, 2022. Let's now turn our attention to desktop processors Raptor Lake S and uncover the fascinating insights it brings to the table. Desktop processors Raptor Lake Corpus support up to 4800 and 192 GB of RAM. 13,600 and better support to 5,600, 13,500 and lower support to 4,800. Intel 600 and 700 chipset support with LGA 1700. Intel 600 series chipsets require BIOS update to achieve support for Raptor Lake S first 6 processor X. By default, Core iX achieves 6 Gs only when using thermal velocity boost with sufficient power and cooling. Processor branding model cores threads base clock rate turbo boost to turbo boost 3 iris C graphics smart cache power price USD P core E core P core E core P core E core P core use max freak base Core iX 8 16 16 16 3.2 Gs 2.4 Gs 5.4 Gs 4.3 Gs 5.8 Gs 32 UC 3 Gs 2.2 Gs 5.7 Gs 125 W $589 of cost and $564 $13,900 Gs 1.5 Gs 5.2 Gs 4.2 Gs 5.5 Gs 30 to 1.65 65 W $219 of cost and $524 at 1.1 0.8 Gs 5.1 Gs 3.9 Gs 5.3 Gs 30 to 1.65 Gs 35 W $106 W Core iX 88 3.4 Gs 2.5 Gs 5.3 Gs 4.2 Gs 5.4 Gs 1.6 Gs 30 MB of cost and $384 $13,600 700 2.1 1.5 5.1 4.1 5.2 30 to 1.6 65 W 219 W of Cuspan $359 at 1.4 ones 4.8 3.6 4.9 30 to 1.6 35 W 106 W Core IRC 612 3.5 2.6 5.1 3.9 Raspan 1.5 24 MB of Cuspan $294 13,600 2.7 to 5 3.7 30 to 1.55 65 W 154 W $255 at 1.8 1.3 4.8 3.4 35 W 92 W 13,500 2.5 1.8 3.5 65 W 154 W $232 at 1.6 1.2 4.6 3.2 35 W 92 W 13,404 2.5 1.8 3.3 2420 MB 65 W 148 W $221 of Cuspan $196 at 1.3 4.4 streaks 24 1.55 35 W 82 W $221 Core I 13,148 Raspan 3.4 Raspan 4.5 Raspan 1.5 12 MB of Cuspan 58 W $109 at 2.5 4.2 24 1.5 35 W 69 W $134. In the following section, we'll be immersing ourselves in the captivating world of Raptor Lake Refresh. Raptor Lake Refresh is Intel's codenym for the 14th generation of Intel Core processors. It is a refresh and based on the same architecture of the 13th generation with clock speeds of up to 6.2 GHz on the Core IRCs, 6 GHz on the Core IRC and IRC, 5.6 GHz on the Core IRC and IRC, and 5.3 GHz on the Core IRC and IRC, as well as UHD Graphics 770 on non-F processors. They are still based on the Intel 7 process node. Introduced on October 17, 2023, these cores are designed for the LG A1700 socket, which allows for compatibility with 600 and 700 series motherboards. It is the last generation cores to use the Intel Core I and I naming scheme, as Intel announced that they will be dropping the I prefix for future Intel Core processors in 2023. The 14th generation CPU does not feature any major architectural changes over Raptor Lake, but does feature some minor improvements. The 14th generation CPU was widely criticized as a last-ditch effort to beat AMD's Zen 4 with Vcache. Intel's desktop version of the next generation architecture, Meteor Lake, was cancelled and the Arrow Lake architecture was not yet ready for release. In addition to the Raptor Lake S refresh desktop processors, Intel also launched 14th Gen Raptor Lake HX refresh mobile processors in January 2024. Cores in bold below feature ECC memory support only when paired with a motherboard based on the chipset according to each respective Intel Arc product page. In this section, we'll be deep diving into Core and Core Ultra, unraveling its complexities and uncovering valuable insights. Starting with the Meteor Lake Mobile series launched in December 2023 with the exception of Raptor Lake HX Refresh, Intel introduced a new naming system for its new and upcoming processors. The numbers 3, 5, 7 and 9, which denote tiers, are still used, but the letter I is dropped, and there is a new Core Ultra sub-brand. Like AMD with their Ryzen 7000 mobile series and later processors, Intel now refreshes older architectures to be sold as more affordable mainstream processors, while the latest architectures are released as premium products under the Core Ultra brand. This new naming system also cuts the number of model number digits down from 45 to 34, e.g. Core X series instead of Core X or X series. Intel no longer refers to iterations of product series under nth generation anymore, instead using Series N. Otherwise, the latest series launched in December 2023 would be called 15th generation. In the next segment, we'll be exploring Series 1 and its implications for our subject matter. The Series 1 of core processors consists of the Raptor Lake U Refresh Mobile series released January 2024 under the Core brand, and the Meteor Lake U Mobile series released December 2023 under the Core Ultra brand. Overview of Mobile Core Series 1 models. Get ready for an enlightening exploration as we dig into Meteor Lake and understand its role in the broader context. Meteor Lake is Intel's codename for the first generation of Intel Core Ultra mobile processors, and was officially launched on December 14, 2023. It is the first generation of Intel mobile processors to use a chiplet architecture, which means that the processor is a multi-chip module. Tim Wilson led the system-on-a-chip development for this generation microprocessor. As we transition to the next segment, let's unravel the mysteries surrounding process technology and gain a fresh perspective. Due to its multi-chip module MCM construction, Meteor Lake can take advantage of different process nodes that are best suited to the use case. Meteor Lake is built using 4 different fabrication nodes, including both Intel's own nodes and external nodes outsourced to fabrication competitor TSMC. The Intel 4 process used for the CPU tile is the first process node in which Intel is utilizing extreme ultraviolet UV lithography, which is necessary for creating nodes and smaller. The interposer-based tile is fabricated on Intel's URFL or Intel 16 process. The URFL Thin Field Effect Transistor FinFET low-power node, first announced in March 2017, was designed for inexpensive low-power operation. The interposer-based tile is designed to connect tiles together and allow for die-to-die communication, which does not require the most advanced, expensive nodes, so an older, inexpensive node can be used instead. Mobile processors. Meteor Lake H and support P-Core Turbo Boost 3 running at the same frequency as Turbo Boost 2. Meteor Lake U. The integrated GPU is branded as Intel Graphics but still use the same GPU microarchitecture as Intel Arc Graphics on the H series models. All models support true memory except 2 and 2. Get ready for a captivating exploration as we unravel the layers of processors for Internet of Things IoT devices and embedded systems Meteor Lake PS and their profound significance. Processors for Internet of Things IoT devices and embedded systems Meteor Lake PS. High power. Will and support P-Core Turbo Boost 3 running at the same frequency as Turbo Boost 2. Low power. The integrated GPU is branded as Intel Graphics but still use the same GPU microarchitecture as Intel Arc Graphics on the high-power models. Let's now zoom in on Lunar Lake and uncover the hidden gems that lie within. Mobile processors. With our curiosity piqued, let's embark on a dedicated exploration of Arrow Lake and its fascinating intricacies. Arrow Lake is Intel's codename for the second-generation Core Ultra processors. Announced on October 10, 2024, and released on October 24, 2024, Arrow Lake is the first series of desktop Intel processors not to feature a monolithic design, instead adopting the chiplet design used on Meteor Lake. Intel primarily markets this product as being on par with Raptor Lake in performance whilst being much more power efficient. The processors use the LGA1851 socket with the 800 series chipset. Leave a comment below and let me know what you thought of this video.